Welcome to this video explaining this week's task on fractions. Basically what we're going to cover is changing to and from improper fractions and mixed numbers, adding and subtracting mixed numbers, multiplying mixed numbers, and dividing normal fractions and mixed numbers I should say. Okay, so to change 3 and 6 and 3/5 I should say, to an improper fraction, what we have to realise that each of these 6 is made up out of 5/5. So I have 6 times 5 plus the extra 3 that's already there. That's the number of fifths I have in total. That then becomes 30 plus 3 that I already had is 33 over 5. If we change 4 and 3/8 to an improper fraction, that will become similarly 4 times 8 plus the 3 that I've already got. So 32 plus 3 gives me 35 over 8. Changing back is very simple. Basically what we need to do is we need to realise that 27 over 4 means 27 divided by 4. So when you divide that in, that becomes 6 remainder 3. So that's 6 whole times and 3 left over. So that's 3 out of the next 4. Similarly, 42 over 4 means 42 divided by 4. So 10 remainder 2. So that's 10 and 2/4. Now we have to make sure that we cancel down. We would never leave 2/4 as 2/4. We would change that to a half, so 10 and a half. When we combine fractions, either adding and subtracting, we have to remember that those are different rules to when you multiply or divide. When we have mixed numbers here, the best thing to do is to deal with the whole number part of the mixed number, and then we just deal with the fraction separately. So 2 plus 3 gives us 5, and then I've got a third, add a quarter. Now the rule with adding and subtracting fractions is that you can't do this until the denominators, the bit below the line, is the same. Okay, so you have to be dealing with the same thing, and the best way to deal with that is to just simply multiply the 3 by the 4 to give me 12. And because I multiplied over here, I multiplied by the 3. That's 1 times 3 gives me 3. And over here, I multiplied by 4. So we multiply the top by 4 as well. So 1 times 4 gives me 4. So that becomes 5 and 4/12 plus 3/12. So 5 and 7/12 in total. When we subtract, we have to be quite careful. I mean, it's a similar process, but there's one that I've given an example here which demonstrates what I mean about having to be quite careful. Okay, so I've got 5 and a quarter, take away 2 and a third. So 5 take away 2 gives me my 3 up front. And then it becomes a quarter, take away a third. Now, a quarter is actually less than a third. So I'm actually taking away more than I've got. What that means is the answer is going to be negative. So in a similar way to what I did before, that becomes same on the bottom, 12ths. So that's 3/12, take away 4/12, giving me minus 1/12. So that's 3 take away 1/12. Now if you think about each of those 3 whole digits, those are made up out of 12/12. So if we convert one of those 3 into 2 and 12/12, take away 1/12, it leaves us 11/12. So 2 and 11/12 is my final answer. When we multiply simple fractions, we just simply multiply the top and then multiply the bottom and then look to cancel. Or cancel first if you spot it. That's the method that I'm going to use here. So in order to deal with mixed numbers when I multiply them, I first have to change them into top-heavy fractions or improper fractions. So 3 times 4 plus 3 is 15 over 4. 2 times 3 is 6 plus 2 is 8 over 3. So 15 times 8 over 4 times 3. But I have spotted that 15 and 3 are both in the 3 times table. So here, what I'm doing is I'm going, that's 1 times 3 and 5 times 3. So I'm going to change the numbers to those number of multiples of 3. And I've noticed also that the 4 and the 8 are also in the 2 times table, so I'm dividing by 2. So that's going to give me 5 times 2 over 1 times 1. I would recommend using this method because it means that you don't wind up multiplying out very, very large numbers and then trying to cancel them. So 5 times 2 is 10, over 1 times 1 is 1, so my answer's 10 over 1, but because we're not 5 pupils, we will actually lose a mark if we actually leave it like that, so we have to reduce that to 10. Similarly, 4 and 1/8 I should say, times 1 and 1/11. That gives me 33 over 8 times 12 over 11, giving me 3 times 3 over 2 times 1, so 9 over 2. When we divide fractions, we have to remember that 6 divided by 2 is the same as 6 divided by 2 over 1. Okay, now this is exactly the same, if you remember back further down the school, that's the same as finding a half of 6. So 6 divided by 2 is the same as finding a half of 6, so 6 times a half. The answer's 3. If you notice, the 2 over 1 has flipped upside down to give me 1 over 2, and my divide has changed into being a multiply. So I'm going to use that same sort of thing happening here. What's going to happen is the fraction on the right, the one that's dividing into, is going to flip upside down, and my divide is going to become a multiply. So instead of having 5 over 6 divided by 2 over 3, I'm going to have 5 over 6 times 2 over 3. Again, looking to cancel, I cancel through by dividing the 3 and the 6 by 2. By 3 I should say. And that's going to be 5 times 1 over 2 times 2, giving me an answer of 5 over 4. Broadly similar process happens when we deal with mixed numbers. All we have to do is to convert them into top-heavy fractions, and then we deal with exactly the same here. Now, 21 and 3, they do cancel, but be really careful with stuff like this because I have to flip this fraction on the right upside down first. So that's going to be 21 over 5 times 3 over 4, giving me 21 times 3 is 63, over 5 times 4 is 20. Hopefully you found that useful.